Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi and welcome to Geeks for Geeks. Can I have a quick one in the chat if I'm visible as well as equally audible? And this one would quickly mark your attendance too. So, without any further ado, let me introduce myself. Hi, everyone. For those who don't know me, I'm Siddharth Hazra. Currently, I'm an SD intern and mentor intern at Geeks for Geeks. Currently, I'm in my fourth year in Netaji Subhash Engineering College. So, quickly. Okay, Vikash Patel, okay, fair enough. A similar face. Sachin Yadav, okay. Shubham Adarsh Gupta, fair enough. Okay, let me see some. Today I'm very happy. Okay, what is this? Today I'm very. I reject offer of 3 LPA as intern because I get my value after joining this TSA session. Fair enough. A high confidence. I would suggest you that you really work hard. Okay, fair enough. Mm-mm-mm. I'm placed at 7 LP but still preparing for better offers. Finally, a student. So it entirely depends upon the goal of each individual. The focus of some people is something, the focus of some other people is something. Okay, we shouldn't really judge this rat race on the basis of just what LPA per annum we have. Okay, fair enough. So just let me hide this comment. Okay, so I would be quickly telling you what we would be doing today. Today, in the last class, where the day before yesterday, I introduced you to the concept of graphs. Then I taught you about DFS, which is depth first search. And the next thing which was taught was BFS, which is breadth first search. After that, we went on and we did a question which was counting the number of connected components. Okay, and the next today what we would be doing is we would be doing a stream where we would be first discussing about BFS, okay, like how BFS gives us the shortest path, and then we would discuss a question where we would introduce you to the concept of Dijkstra. Okay, then after that we would move forward and we would talk about the easy but kind of, I can say that it is visualized as kind of hard thing, but if understood with the underlying concept of Dijkstra and BFS, it was very easy, to be honest. And okay, and the name is multi-source BFS. Okay, is this Diwali dress nice? This full of watermelons? No, actually, what happened was a little bit of cool weather at the moment. Okay, so I thought that every stream I just wear my t-shirt. Okay, the solid colors polo t-shirt which I'm fond of. So I think so. I thought that I should move forward and experiment with colors. That's why. Okay. So, sir, can I get as an SD intern in second year of SDA? Yes, absolutely. Nice shirt said, bro. Okay, so don't ask me why this, why that, because I am a kind of person who rarely experiments. Like 90% of the time, 90% of the time I move forward with solid colors only. Like you would, if you know me in real life, I only wear like black, red, okay, like not red, maroon, and then white and all. Okay. Apart from this, gifted by GF. No, this was gifted by my D. This shirt was gifted by my D on the occasion of Diwali. Okay, fair enough. I think we can move forward. Let me just start my open board. Okay, so before we move forward with this, so how many of you are acquainted with DFS and BFS? Okay, so quickly give me a one. If you're not acquainted with DFS or BFS, I would give 15 minutes of time to again recapitulate what we have done in the day before yesterday. Quickly tell me. GF ने बोला है fitness or shirt I know. अरे भाई भाई भाई. Okay, consider my comment, please. Yeah, absolutely, Nekaj. I want a job in Google, Microsoft. Work hard, bro. What can I tell? Quickly, quickly, quickly. Okay, so if you already, so I'm just repeating the question. If you already know the concept of BFS and DFS, quickly give me a one. If you're not aware of this, okay, quickly give me a zero. Bro, give me your opinion, please. On what thing, bro? I have an intern by Amazon. Okay, a 34 lakhs, but I'm not sure that I will work or not. Why so? Like, what is your reason? It entirely depends. Okay, okay, very few people. So I would just quickly recapitulate what we have done in the last class. So, mm, okay, fair enough. So we would move forward with this. All the comments that are not related to this question would be answered after I finish the explanation. Fair enough. So we learned about what is graph and what is DFS. So DFS is a depth first search. It can be implemented recursively as well as it can be implemented iteratively. So what is DFS basically is that suppose we have given a graph. Okay, we have given a graph. Okay, so what we do is we first go down and we finish off all this and then we go to this. Okay, this is the small thing about DFS. That is why it is known as depth first search. The example that you need to remember is that suppose I start off reading about physics. Okay, and suppose I start off reading about biology. Okay, so in physics, suppose there is magnetics. Okay, magnet, and this is suppose plant. I don't know much about biology. Okay, fair enough. So moved forward, and when I started off with magnets, I won't leave it midway. Rather, I would complete this whole thing, and then I would come to biology and then finish this whole thing. Okay, it's not that like I would read the first magnet and then I would come to read plants, then I would come to read electricity, then I would read to come about cells and all. Okay, so it entirely depends. Like we would first finish off this subject and then move to another subject. Okay, this should be visualized like this. Okay, now what is BFS? BFS. Okay, BFS. BFS is a very, like, what I can say, like it is life. Okay, like BFS is like life. How it is life? Suppose we have this. Okay, like we are first born. Then we learn to write. Okay, so we write Hindi. Okay, we write English. A general Indian student. Okay, we write Hindi and we write English. Okay, like I'm from Jharkhand, so my next language was Hindi. So okay, first we learn to write. Then we learn to write both the things. Then we start to learn. Like here also we would learn an essay in Hindi. Here also we would learn an essay writing in English. Here also we would learn a letter writing in Hindi. Here also we would learn letter writing in English. So if you observe that the approach is very different. Earlier we had to first finish one subject and then we were coming back. And then we moved to the next subject. But this time, if you see, the approach is really very different. Okay, like first we learn about Hindi and English. Okay, then we learn about letter writing, essay writing in Hindi as well as in English. So if you observe that these all things are working in parallel form, and here we are working in the depth form. Okay, so this was the basic of BFS and DFS. People who replied with a zero, quickly give me a one in the chat. Okay, quickly give me a one in the chat, and I would move forward with Dijkstra. Okay, DSA is enough for software engineering? Absolutely not. Most of the times, like you can relate DSA with like this thing that DSA is used for optimization and development is the main thing. Okay, most of the time. What should we have to develop logic for thing in programming? Yes. Which are the questions we are gonna solve today? Nothing is given in description. So we would be implementing the Dijkstra algorithm. Then we would be finishing off this question, okay, which is written, and then I would be giving you the homework of rotten oranges. Okay, this has been catered. Same BSA with tier 3 college. So this tier 3 college and tier 2 college and tier 1 college. So to be honest, I am a tier 3 person, but I don't really support this statement like tier 3 and all. Okay, why? Because you have enjoyed your life in the 11th and 12th. Okay, that is why you are in tier 3. Now you need to work hard at this point of time, and you need to get placed in a good amount of job. Okay, I understand that you need to work much more than the people at tier 1, but it entirely depends. Okay, like you have enjoyed life at that point of time. Now you need to work hard. Okay, being a tier 3 guy, I am claiming this. Okay, it's not because I'm a tier 1, so I don't support this. Okay, I belong from Netaji Subhash Engineering College, where not a single company visits for internship. Okay, so please understand this. There is nothing known as tier 3, tier 1, tier 2. Everyone, be it tier 1, be it tier 3, they have worked hard at some point of time. You need to work hard at some point of time. Okay, there is no difference, to be honest. Okay, you both are in the same page. Can you please suggest which GFG should there are tons of questions in lead code GFGs? Can you please comment? So basically, you can take either of the popular sheets and then you can move forward, and after that, you can move forward with practice with either of the websites. Okay. Okay, ये Q&A session थोड़ा बाद में करते हैं. First, quickly give me a one. Okay, quickly give me a one if this is understood. Quickly give me a one. Post one if done with BFS and DFS. Quickly. Quickly post one in the chat. I need to move forward. I need to do a lot of things today. Dijkstra, multi-source BFS, and all those things. Hi Ujjwal, how are you? सब बताऊंगा. अब क्वेश्चन कंप्लीट करके डाइक्स्ट्रा का एक्सप्लेनेशन के बाद मैं समझाता हूँ कैसे प्रोडक्ट बेस पे जाना क्या करना है. Okay, a simple explanation would be there are tons of roadmaps in the form of videos, and they are much more successful than me. Okay, I consider myself as a teacher. Okay, so I'm just explaining things. You can see the videos from either of the successful folks who have already made a significant step in his career. Okay, so let me just and sir ना बुलाओ आप मेरे को भाई भाई बुलाओ भैया बुलाओ सर मत बुलाओ. Okay, बहुत awkward लगता है. Fair enough. So we would be moving forward with the Dijkstra. Okay. Quickly read this problem. आज का टॉपिक ऑन एल्गोरिथम ग्राफ्स. यस, मैं ग्राफ्स थोड़ा कंप्लीट करने में लगा हुआ हूँ. Okay. So let me see if I can. Okay, quickly read this problem. I would be giving you a time frame of 2 minutes. Quickly read this problem. Till then, let me just turn on my preview screen. Okay, the UI has changed for YouTube. Quickly read this and then we will be moving forward. So this is the timer. The next 1 minute. When you have read the question, now there is 1 minute left. If you have read the question, quickly give me a one. And then I would explain you the question too. 13, 10 seconds left to be specific. What about others? Ujjwal, Ritesh, Mukesh, quickly let me know. This Mukesh Sharma has spammed a lot. Baap re baap. Sneha Roy. Okay, fair enough. So let me just stop this timer and then we can move forward. Chalo. So what is this basically given? Okay. So I would explain you the things in a very simple manner. Okay. You are given that there is a source node that is provided. Hi Yash, how are you? Okay, there is a source node that is there, and then you have some other nodes too. Okay, and these are all the other nodes. Now they have some weight associated with it. Okay, like we have here 5, we have here 2, we have here 3, we have here 4, we have here 2, 1, and then suppose 9. Okay, so the thing is that if I go from this, so let me just mark it. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. यश के काफी फैन है. Okay, fair enough. So suppose what I can say is from source to 2, if I travel, then the cost encountered would be 2. From source to 2 to 3, if I travel, the cost encountered would be 2 plus 3. From source to 6 and then 5, then 2, then 3, if I travel, the cost encountered would be 9 added to 1, added to 2, added to 3 itself. Okay, fair enough? Okay, so what you need to do is you need to find the shortest path. Okay, so I will just have it. Okay, shortest path from source to others. Okay, so the very first, to make the problem seem very simple, what I would do is I would say that they have no weights. So now tell me, if they have no weights, what would be the way to solve it? Okay, first tell me this. Then we would talk about when the graph has a weight. Okay, simply first understand that this graph is an unweighted graph. So now tell me, how would we find the shortest path from source to others? Quickly reply me. How would we do it? Okay, Sneha, you are absolutely correct. What about others? Shubham bhai, no don bro, only one don in. Okay, so Yash is talking about, so the person, so Yash is talking about himself, tagging the name of mine. Okay, fair enough. So we would simply do a BFS. So if the graph is unweighted, okay, or I can say simply that no weights. If the graph has no weight, then it is nothing but a simple BFS. Okay. Now, if the graph has some weight associated with it, okay, okay, like suppose we have here 1, 2, 3, 2, 5, 7, and 9. So, in this scenario, what would be the algorithm to have this? Okay, so I would simply sum up everything, okay, in a pen and paper, and then I would be moving forward. But as I have not talked about this Dijkstra now, so the algorithm used would be Dijkstra. For those who don't know it, okay, for those who don't know it, what I can do, I will need to do is I will just sum up everything from here. Okay, so we are talking about single source shortest path, single source shortest path. Okay, SSSP. Okay, single source shortest path. So the graph, if it is unweighted, okay, if the graph is unweighted, then the very first thing you need to learn is BFS, that is breadth first search. Okay, if the graph contains weight, if the graph contains weights, okay, now there are two types of weighted graph. The first graph is that it has no negative cycle. Okay, this is the very first one. Then there is, okay, then there is that we can say that there is negative cycle. Okay, then, so if the graph has no negative cycle, if the graph has negative cycle, okay, what would be the algorithm to solve this? And we are only talking about single source shortest path. So tell me the algorithms. The very first algorithm for no negative cycle, it is Dijkstra. Okay, explain negative cycle. Okay, so I will just quickly copy the diagram of negative cycle, and then I would be able to show you. Some of the weights is like negative one. Let me just show you. Okay, this was enough. I think. Okay. Mhm. Okay. So negative cycle. Okay. The first is that from the negative cycle, if we just move, this is one, this is minus one. Okay, that is 0. 1 plus minus 1. 1 and minus 1. 0. And then again minus 1. Okay, then again minus 1. And then again minus 2. Okay. So basically this is a negative cycle. So I would explain you when after we have learned about Dijkstra that why Dijkstra does not work on negative cycle. Okay. Mm, just a sec. Actually detect a negative cycle would be okay. What about others? Vivek has answered. What about others? Quickly fill this up. Quickly fill up this. Okay, what about the others? Quickly. Why so less people here today? If the problem is resolved, then we need to maximum the longest path, then we can use. If the problem is to find the maximum or the longest path, then we can use. Is this correct? No, absolutely not. Okay, so there are mixed answers. Okay, for negative cycle. Okay, so this remains as a homework. Okay, because we won't be going into this. Like Belmont Ford is altogether different. Detecting a negative cycle and all is the next session. As of now, okay, so there were two clashing of answers. Like we can't do it if it has negative cycle. And the next is the people are telling that it is Belmont Ford. So so you draw the conclusions for this and reply me in the chat who is correct. Okay, because we won't be going to that direction. So as of now, please understand that if this is an unweighted graph, then we need to move forward BFS. And if it has no negative cycle, then we need to move forward with Dijkstra. Okay. By the way, this confusion that is going on for the last one, we would be catering this when I would be taking the next session over this. Okay. So the next says that if so, tell me when there is only two kinds of weights. Okay, two values of weight. Two values of weight. So when there are only two values of weight, okay, there is one more algorithm that is there, and it is 0 1 BFS. If you didn't know, I'm telling you. This is an algorithm which is very less likely to be asked, but still for the information, I'm just telling you. And it is a very interesting algorithm. Feel free to just read about it. Okay, and then solve some more questions over it. Okay, so now the thing is that how we are computing about Dijkstra. Okay, like how does Dijkstra really solve this? Okay, when we have positive weights, like what is the whole idea of Dijkstra? So Dijkstra is to find single shortest path in weighted graph. Okay, in weighted graph and no negative cycle, no negative cycle, and the weights are positive. Okay, so it is given. If the weights are positive, it should be given. Yes, the weights are non-negative. Okay, no negative weights. Okay, it is given clearly. Okay, it is mentioned somewhere. Graph connected adjacency list. Second, you are given the find the shortest possible source you are able to return the distance from. The graph does not contain any negative weight cycle. Okay, so there are no negative weights. This confirms this. Okay, send the link for there is one algorithm for negative. Okay, send the link for 0 1 VFS. You couldn't do this. Okay, fair enough. So this is there. So now the graph is there. So just let me. Yes. So how do we really solve it? Okay. So just let me see. Yes. Okay. Let's take up this example. Okay. So the idea of Dijkstra is that it follows a greedy idea. Okay. It is a greedy algorithm. So greedy algorithm. Okay. So we need to find single source shortest path. Okay. So need to understand single source shortest path for the single source shortest path, and it is a greedy algorithm. Please don't send me not related to the question. Okay. So okay, fair enough. So the greedy algorithm, and then it is it starts with the minimum weight. So just try to think that if someone is of greedy algorithm, okay, like I have a greedy mind. Okay, so let's just suppose. What do you mean by this greedy algorithm? Reveals the whole idea of Dijkstra. How? Suppose I am a human being. Okay, I have a human being, and now there are some cities. Okay, this is city A, this is city B, this is city C. Okay. Mhm. Yes, this is correct. And then we have here 1, 2, and 3. So if I have a greedy mentality, okay, like if I'm just, even if you don't know what is greedy or not, that doesn't bother us. Suppose if I have a greedy mentality and I want to save money as much as possible, and I want to visit this ABC. Okay, my whole aim is to visit these three cities, that is A, B, C, and the cost to move from A to B is one, and the cost to move A to C is one, and the cost to move A to B is B to C is three. Okay, this is the cost that is given. I want to save money, and I want to visit all three cities. If I want to visit all three cities, I want to save my money, then what is the greedy strategy that I would follow? I would start off from the minimum weight. Okay, so my strategy would be I would start with minimum, and then I would simply go to next minimum, next maximum. Okay, whatever be the way to reach this, but this would be my strategy. Like I would save money and I would start with the minimum. I would have this greedy mentality or not. Simply give me a quick one in the chat. Quick one in the chat. Like if you are able to relate with this example. Okay. So is Dijkstra only for directed or undirected graph? It doesn't bother us. If it is directed or undirected, it would solve the purpose. A small noise is coming from your side. Okay. Is the noise now gone? Let me just check the windows. Yes, it is closed. Yes. So is the noise now gone? Quickly confirm. Who was this person? Shubham. Quickly confirm if the noise is now gone or not. Start with the minimum path. Next min. Next min. Okay. Everyone agrees me with till this point. Okay. Chalo. We can move forward with this. Mhm. Okay. You tell me whenever these all things happen. Okay. Like I'm not aware. Okay, like I can't really hear myself. I have my preview screen muted, so I can't really keep a track. Okay, so I would just move forward. Okay, so I would start with the very minimum weight, and this is fine. Okay, so now the very next thing is that if this is a greedy algorithm, what we would do is we would first visit this one. Okay, the idea is to first visit this one or whatever be the source. Okay, first we would visit the source with the cost as 0. Wherever we are standing, we would visit it with the cost of 0. Okay, visit source with cost of 0. Visit source with 0 cost. This is the very first thing that you should do. And now the next thing is visit the minimum, okay, visit the minimum weight. Okay, visit the minimum weight that is available to us. Okay, visit the minimum weight that is available to us. And the next thing is that if visiting the minimum weight, okay, like suppose, so first what I would do, I would go from A to C and then A to B. Okay, so the cost encountered was how much? If I go from A to C and C to B, the cost encountered was 5. Now if I go from A to B, now the cost encountered is just 1. So I am able to improve, okay, I am able to improve from the previous cost. Okay, so like see, earlier I visited, okay, the cost was 5. Now I'm able to narrow down my cost to 1. Okay, this is known as what? Can anyone tell me? This is known as relaxing, okay, in terms of graphs. Like if we are able to relax, then we say that we have narrowed down. So I can say that if relaxation is possible, if relaxation is possible, okay, if we can relax it, then we would, if we are able to relax it, then update with new. Like it is very normal, na? Like suppose I go from A to B, so earlier I had a cost of 5, so I would simply write to visit 5 you need to allow a cost of 5. Then I visit from A to B, we have the cost of 1, then we have the cost as 1. So this is the very small algorithm that you need to remember. The very first algorithm is that greedy algorithm. Whenever you see this greedy algorithm, Dijkstra, you draw a man, and then you write ABC, and then whatever you would do in real life, do it with this graph also. Like visit source with the zero cost, then visit the minimum weight that is available to us. Okay, whatever is available to us at this point of time, visit those also. And if we are able to relax, what is able to relax? If we are able to improve on the cost of visiting another cities, then we would update it. Now am I clear with this or not? Just give me a quick one in the chat. Okay, like if this is clear, Dijkstra is 90% clear. Okay, Dijkstra is 90% clear. Okay, so try to keep up with the example. Okay, but not everyone, no, but not every time the small gives us relaxing. Gives us relaxing. Once again, repeat please. Which part do you want me to repeat? Greedy algorithm 1, 2, or 3? Which one? But not every time the small weighted gives us relaxing. Yes, I'm not telling that not every time it would give. I'm just telling that if you are able to improve from the previous cost, then it is known as relaxing. I didn't told it. Okay, so I'm just telling you again. Okay, suppose this is me. Okay, this is me. Let's take a funny example so that everyone would understand. And suppose these are the two available option. Okay, like this is my friend one. Okay, whom I like. Okay, this is my friend two whom I like. Okay, fair enough. Suppose I like both of them. Okay, they are kind of best friend whom I am in love with. Okay, like very common thing that happens with us. Okay, so now suppose I went out with her. Okay, and I had a cost of 10 rupees. Okay, now I went out with her and I had a cost of 5 rupees. So I am able, so I suppose my whole agenda is to just roam with either of them. If my whole point is to roam with either of them, then earlier I had a cost of 10. Earlier I had a cost of 10. Now I have a cost of 5. Okay, so if I'm able to improve from my previous cost, I would say this as relaxing. Now let us understand in terms of graphs. In the same manner, suppose I visit from 1 to 2 and 2 to 1. Okay, the cost encountered is 9. So first I would write it. Then I go from 0 to 1. The cost encountered is 1. Now if my whole point is to just visit 1, okay, I don't care about the path. Like in this example, I didn't care about who with whom which friend I'm hanging out. My whole point is that I just want to hang out with either of them. Then I would take the person which is giving me a minimum cost. In the same manner, if I'm not concerned about the path I take, I'm only concerned about the cost I encounter, then I would be taking this one, not this one. And if we are able to improve from the previous thing, then it is known as relaxation. Now, am I able to clear your mind? Give me a quick one in the chat. Okay. Okay, you don't need to say me, please. Okay. Quickly give me a one. Like Akash, Mekshat, Akash Mekshat. Okay. I think normal gives us answer. Would handle anything. Yes, absolutely, Snehara. SK Chand, quickly give me a one. SK Chand, SK Chand Basha. Okay, fair enough. So now the idea is that this is a greedy algorithm. We would visit the source with the zero cost. So let us first try to help this. So first we would say, so I would just copy this. Okay, see this whole thing. How we are getting the minimum cost. So here let us make this as the source. Mhm. Okay. So if you remember this, okay, if you remember this, then you should be able to just see this and write the algorithm. Okay, like the implementation or how to do it should be clear from these 3 points only. I care about that. Okay, I would show you the algorithm, show you the dry run, and you would say what was the algorithm. I don't remember it. That shouldn't happen. From these 3 points only, I should be able to derive the algorithm. Please see this with absolute care. Okay, first it is told that I would visit the source with the zero cost. So first I would have a cost thing. Okay, so let us have a cost. Zero, one, and two. Okay, this would be the node that is 0, 1, and 2. So this is what the node, this is the cost encountered. Look, as the path weights are always positive, okay, like if I go out, I need to spend money. So what is this kind of thing if the path is always positive? Path is always positive means that I would go out and I would definitely encounter some cost. It is not the scenario that I would go out and someone would pay me for going out. Okay, like for most of us, this is the scenario. Like अगर हम बाहर जाएंगे घूमने तो हमें हमारा पैसा खर्चा होगा. Okay, ऐसा नहीं है कि घूमने के लिए हमें पैसा दिया जाएगा. Okay, so we know that definitely the cost would be zero or more than zero. We know that. So we would initialize the cost of everyone with -1. First, we would initialize the cost of everyone with -1. Am I clear till this point? Quickly give me a 1 in the chat. If I'm not clear, quickly give me a 0 in the chat. Okay. So now let us move back. We are told that we need to visit the source with the zero cost. If we need to visit the source with the zero cost, okay. So what was the source? Source is 0. So I would visit this source with the cost of 0. Okay, I would visit this with the cost of 0. Okay, fair enough. Now, I would go and I would go from the source to all other neighbors. So what was the cost to reach zero? First tell me that. So cost to reach zero is zero. The cost to reach zero is zero. Okay. So from zero, I would go to all other. Okay. I would go to all others. Why initialize with -1, not 0? Because it is a given that the weight can be 0 also. It is given. See, like somewhere it is free to wait. So see, it is given like, is it given? I don't know. ADJ of IJ is equals to 0. Okay. Okay, let's do it with the very simple one. Okay, if you want. Okay, let's do it with the very simple one. This is 1000. We know that at most the cost to visit. Okay, so we would take a very big number. Okay, so here we know that the maximum cost would be 9. So let's take a very big number initially. Okay, let's take a very big number, 20. Like take some number which is not feasible. Okay, like what do we do in real life? Okay, if we are going out and we know that at max I should spend around 500. So what do? You keep yourself, okay, you keep with yourself a 1000 rupee note or 600 rupees note. In the same manner, if I am trying to visit all of them with the minimum one, I would go out with the cost of 20, because I know by no means I would encounter a cost of 20 to everyone else, either of them. Okay. Okay, infinity, I don't think infinity thing, yes, we can say it is infinity. Many books and many video explanation use the thing known as infinity, but I don't think infinity would be the proper thing that you would be able to relate it with a real life example. Okay, integer max infinity, I don't think you would be able to relate it with a real life example. More relatable it is, more feasible it would be. Please understand this. Okay, so I know that by no means I would encounter a cost of 20, so I have written 20. So what do we do? अगर हम कहीं बाहर जा रहे हैं और हमें पता है कि at max हमारा खर्चा 500 ही होगा, तो हम लोग 500 से कुछ ज्यादा लेके जाते हैं. Okay, same thing I'm doing here also. Okay, I should be clear till this point. Okay, so now first what I can tell, that visit the source with the zero cost. So I would visit the source with the zero cost. First I would visit this source with the zero cost. Then the cost to reach zero is 0. Now we would try to visit the neighbors of 0 and we would see. So cost to reach 0, then we would visit the neighbors of 0. So if the cost to reach 0 is 0, if the cost to reach 0 is 0, then from 0 to 1, the cost would be the cost to reach 0 plus 1, that is 1. If the cost to reach 0 to 2 is equal to 6, how 6? I'm just telling you. Okay, like suppose there is a friend of mine. Okay, there is a friend of mine. Let's take the example. What, how this is like this? Okay, so let's take this. There is a friend of mine. Okay, this is one more friend. This is one more friend. Okay, this is one more friend of him, and this is one more friend. So the map is like this. Like we boys generally, because we tend to go out more in our locality. Okay, so we generally boys in Indian society have this habit that everyone in the colony knows us. Okay, suppose this person has already walked 5 kilometers. Like एक दोस्त है मेरा जो already 5 किलोमीटर चल के आ गया है, and this friend's house, okay, is 1 kilometer. This friend's house is 2 kilometer. This friend's house is, suppose, let's take 7 kilometers. Then the cost to reach this friend is how much? Okay, the like To reach this friend, this person has to travel how much? Previous plus this cost. That is 5 plus 7. The cost to reach this person is how much? This person has already walked 5 kilometers. Now he need to again travel 1 kilometers. So in total he needs 5.1 kilometers. The cost to reach this friend, he has already covered 5 kilometers. Now 5 plus 7 is equals to 12 kilometers. So if I want to talk with respect to this person, okay, what is this? Let's take name this. This is me. This is my friend Rahul. Okay, this is my friend, suppose Ankit. Okay, this is my friend, suppose Ria. Let's take a very simple name. Okay, so I have already traveled 5 kilometers. So now if I want to travel Ankit's house, then I need to travel 5 kilometers plus 2 kilometers. So in total, I would be traveling 7 kilometers. So how much thing I have encountered? So now in the same manner, if I want to travel Rahul's house, then I need to travel 5 plus 6 because I've already traveled 5. So am I clear with this figure or not? If I'm clear with this figure, this would be automatically clear. So quickly give me a 1 if this is clear. This scenario is clear. Like suppose मैं अपने खर्चे कैसे explain मैं अपने खर्चे कैसे बोलता हूँ? Like मुझे already 10 रुपए खर्चे हो गए. नए दोस्त के पास जाना है, वहां और 5 रुपए खर्चा होगा. So हम ये सोचेंगे ना दिमाग में कि 10 ऑलरेडी खर्चा हो चुका है, अभी फिर से 5. So in total मेरा खर्चा 15 हुआ. In the same manner, if the cost to reach this is zero, be it either, suppose it was even 100, suppose it was even 100, then the cost to reach this one is 100 plus 1, that is 101. And the cost to reach this is 100 plus 6 is equals to 106. Am I clear or not? Give me a quick one. Like हम लोग अपना like we do the balancing of our budget in real life in what form? Like I have already encountered a cost of 100 rupees. Now again 10 rupees, so this is 120 rupees. Okay, in the same manner we would do the cost thing here also. Okay, just related with the real life example. Okay, so now to reach 0, I had a cost of 0. Now I can reach 1 with a cost of 0 plus 1, that is 1. Okay, and 1 is less than 20. So I'm able to relax 1. I am able to relax 1. Okay. Yes, cost of source should be 0. Okay, I'm just giving you the example that even if the value is not 0, this thing remains the same. Okay, fair enough. So now I'm able to relax 1. Why? Because earlier it was 20. Now I'm able to visit 1 with a cost of 1. Okay, I'm able to relax, so I would just keep here 1. Okay, I would just keep here 1. In the next moment, I'm able to visit 2. Okay, so 0 plus 6 is equals to 6. 6 is, so I can visit 2 with a cost of 6, which is better than 20. So I would say that I'm able to relax 20. Okay, so I'm able to relax 20 with the value as 6. Okay, so now 1 is with a value of 1, 2 is with a value of 6. Okay, now comes the twist part. So you observe that when we are writing something here, when we are able to relax, so what is the weight of 1? So now again in the next step we would be moving forward with visit the minimum weight. So what was the minimum weight? The weight of 1 is 1, the weight of 2 is 6. So which one is minimum? 1 is minimum. So we would start with 1. The cost to reach 1 is 1. So the cost to reach 0 would be 1 plus 1, that is 2. And we already have a better. Earlier we had a 0. So पहले कुछ खर्चा नहीं हुआ, अब 10 रुपए का खर्चा हो गया. So 10 रुपए तो अच्छे नहीं है ना. So we won't be able to relax. Okay. If we are trying to visit 2, then it is the value, the cost to visit 1 is 1 and the cost to visit 2 is 1 plus 3, that is 4. 1 plus 3, which is 1 plus 3. Now 4, now let us see what is here. So 4, but here it is written 6. So 4 to 6 से better है ना? So we are able to relax the 6. Okay. So now let us relax this. Okay. Now I would remove this one, and then now 2, 2. So 2 has a cost of 4, 2 has a cost of 4. Now we would see 2's neighbor. Okay. Now let us see this 2's neighbor of 2. Okay. Neighbor of 2. Neighbor of 2. So the cost to reach 2 is 4. So now we would go to 1 and we would say 4 plus 3 is equals to 7. But 7 है, पहले का खर्चा 1 है. Now the cost is 7, but we already have encountered a cost of 1, which is much cheaper. So we won't consider it. Next is 7, so we won't consider it. The next is 4 plus 6, that is 10. So 10 is much higher than 0, so we won't consider it. So at the end, if we are not able to improve, we won't save it. At the end, nothing would be left and we would be saying that yes, this is complete. So if you observe that to reach 1, we have a cost of 1. To reach 2, we have a cost of 4. And to reach 0, we have a cost of 0. So let us write this cost. This is 0, this is 1, and this is 4. So now you can see that how by using Dijkstra we are able to get the shortest path, single shortest path where the graph is weighted. Okay, quickly give me a 1 in the chat. Then we would talk about the implementation. This was the overview of the algorithm. If we are able to improve, we would keep it and then we would visit the neighbors of that. If we are not able to improve, we would simply ignore that. Okay, and we would initialize everything with a very large value. That can't be the cost of, yes, Akash, am I clear? Just give me a quick one. Vivek, Mekshat, Akash, Adat, Nakaj, okay, Sneha, okay, Brahm. Sir, link is not available. I would provide you the link, no? Focus on this. Abhishek and all, quickly give me a one in the chat. The number of live viewers is much more than the number of, okay, the number of likes is more. Okay, quickly give me a one in the chat. Okay. So now if you observe that we want the minimum after each step. Okay, shortest path means minimum cost path. Yes, absolutely. Absolutely. So if you observe that at this point of time, okay, at this point of time, visit the minimum of one available to us. So we have some available things. Okay, like suppose this is 5, 7, 8, 9, 1, 3. So we have something available to us and we want the minimum. So if we want minimum at each step, so what are the requirements we do have? We want the minimum at each step. Okay. We want to remove the minimum because after visiting the minimum, we need to remove that. We want to remove the minimum and then we want to add elements. So tell me a data structure which would be very efficient in handling all of this. Quickly tell me a data structure which by which we can remove the minimum, we can add elements, and we can calculate the minimum at each step. What is the data structure that facilitate this kind of thing? If you are not aware of this, others would answer, and please keep the properties with you like we do in real life. Na? Like suppose Rahul is good with football, I am good with athletics. Okay. Let's say suppose, or let's take the example of athletics. Okay. Let's suppose I am good with 400-meter. My friend is good with 100-meter. My other friend is good with marathon or 800 meters. Some other person is good with relay race. So what we do, we keep a track what is good in what. In the same manner, we need to keep a track and write it somewhere which data structure has this all features. Okay, priority queue, absolutely. So we need to make use of the priority queue. Okay, please write it that priority queue or heap has all these all things that is there. Okay, min heap to be specific. If the removal of maximum is also there, then you can generalize this thing and say max heap. Okay, so now we would be inserting each one of them in min heap and we would be visiting the source and then this is done. Okay, so now let us move to the implementation, how priority queue works. The working of priority queue is altogether a different thing that needs to be mentioned. So now I need to start the implementation. Okay. Okay. So I have renamed the graph with ADJ from G and then source as S lowercase and this as V itself. Okay, so please keep this with concern. Now what we would have is we would have a vector int, okay, of distance array of size v, and we would initialize everything with a very large value, which is not possible. Like we initialized it with 20, which can't be achieved. So we are initializing everything with int max. Okay, like some people were telling, na int max, int max. This is why they were telling, and this is the size of this. Okay, next I would be visiting the source with the cost as 0. So distance of source would be 0. Okay, now I would initialize the priority queue with the pair of int comma int and I would name it as pq. So now by default this priority queue is max heap or min heap. Quickly tell me. By default, this priority queue is max heap or min heap. Quickly tell me. Okay. Quickly tell me if this priority queue is max heap or min heap. So for those who don't know, this priority queue is max heap. Okay. This priority queue is max heap. You can see it like this. Okay. So let us see what is this max heap or min heap. Okay. So priority queue int and then pq. Okay, then we would pq dot push 1 and then pq dot push 2 and then cout pq dot top, pq dot top. You can see like this also. Okay, so let us see which one it is popping out. It should pop out too. So it is popping out the larger value. Larger value means max heap. That is why I told that this is by default a max heap. So if you want to know how to write min heap, okay, the syntax for min heap is absolutely very large or a little bit complex. Okay, so priority, priority queue, C++, STM. Okay, so this is the syntax to create min heap for priority queue. But it might be a scenario that you won't be able to retain this thing syntax in your mind for a good duration of time. Okay, so you might forget it. So I would quickly tell you how to convert a max heap to min heap. Max heap to min heap. Okay, and this is not language specific. This is every language. This is for every language. Like this thing is independent of the language. I give you a general question that how can I convert a max heap to min heap? So anyone who has watched my stream, can you tell me? Okay, yes, absolutely. So what I can do is, so by default, the max heap is keeping the maximum element on the top. Okay, so if I want to convert a max heap to min heap, What I would do is, suppose this is 6 and 5. I want 5 at the top. So before inserting in a max heap, I would multiply it with -1. So if I want to insert 6, I would insert -6. Okay. Now if I want to insert 5, we need to insert -5. So -5 is greater than -6. That is why -5 would be ranked atop if this is a max heap. So now what you need to do is you get the hold of the minimum element. The only thing you need to do is you need to take out the top and then you need to again multiply it with -1 so that you have the original value, okay, and you would be able to convert it with min heap. So the idea is absolutely very simple. The idea is to convert max heap to min heap. The very first thing you need to do is multiply it with -1 before pushing, and then again multiply it with -1 after popping. This is absolutely very simple. And this is the very general thing. Then we get absolute, then we can get absolute. Okay, fair enough. So quickly tell me, we need to multiply it with -1 before pushing and multiply it with -1 after popping out. So a max heap would be converted to min heap and min heap would be converted to max heap. Quickly give me a 1 if this is clear. If this is not clear, give me a 0. I would be telling you how this is working. Quickly give me a 0 or 1. Quickly. For those who it is not clear, quickly just do it in a pen and paper and then you would be able to see this. For anyone else other than Adarsh Gupta for which it is not clear? For anyone else, okay, I would just tell you that how this is working. So max heap is what? It keeps up in the sorted order. Okay. So suppose I have this max heap as 3, 2, and 1. This is max heap where the top element is 3 and the bottom element is 1. Okay, we get the access of the top element. Now this is what? This is max heap. Now this is min heap. If I multiply the same thing with -1 and I keep it in a min, so if I multiply the same thing with -1, just see what is happening if we multiply with -1. If we multiply it with -1 and then we again keep it in the max heap, then you would see that it would be stored somewhat like this: -1, -2, and -3. If we just multiply it with -1, both of them is max heap. Both of them top element is this. Okay, the only difference is that if you're multiplying it with -1, this ordering gets opposite. So we are taking advantage of this thing. That is why if you observe that we are able to convert max to min by just multiplying it with -1. The only difference is that we have a minus value, we have a minus sign that is present in front of that element. Okay, so what we do is we take out that top element to remove that minus element. We again multiply it with -1. We again multiply it with -1. And we again multiply it with -1 so that we get the original value in the min heap. Now am I clear? Muhammad Konaneen and Adarsh. If you are still not understanding, please give me a 0. I would be more than happy to explain a 0 again and I would be explaining again. That's not an issue. But just see why this -1 is making all the difference. Muhammad Konani. No, do the same thing. If the value is negative, the value is positive. Okay, this thing remains the same. Okay, okay, fair enough. So we would be moving forward. Now the priority queue, still if it is a max heap, I don't think it would be a problem to us. Okay, so we have a pair, so pq dot push. So we would visit the source with the cost as 0. Okay, so we would visit, so first one would be the cost and the next one would be the vertices. So I would just have it here. Okay, so this is cost. Okay, so this is cost and this is the node. Okay, so this is the cost and this is the node. Okay. I think yes, this is fine. Okay, so we would push it. Now, while we don't have anything, we would keep doing it like we do in the case of DFS. Okay, so we would first take out this minimum element. Okay, so we would first take out the node. Okay, so node is equal to PQ dot node is equals to PQ dot top dot second. Okay, top element second one is the node. Okay, top element second one is the node, that is why this is second. Okay, this is the node, and then we have the element, we need the element or the weight which is already saved in this distance array. If you want it, I can say that the original weight is, well, it is just very easy, the distance of node, this of node. Okay, then we would visit the neighbors of this one. So first we would pop out that. Okay, like we have saved the value, we would pop out that. Next, we would move forward and we would start visiting it. So for int I is equals to 0, for int I is equals to 0, and then I is less than g of node, okay, dot size. Okay, this is just traversing the graph that is given, and then I plus plus. Okay, so now the current, okay, so the current res is equals to g of node and then I that 0. What is the very first value? So if you observe, the very first value is, let's see, so what is given, denotes that there is this containing two integers where the first denotes j and where the first denotes containing the list j. J means this is the first one, that is the node. Okay, so this is the node. This is the node, and the next one is second integer corresponds to the weight of that edge. So if I want the weight of that edge, this is the current neighbor of this. Okay, so nodes neighbor, this is the nodes neighbor node, nodes neighbor node. Okay, and then we want the weight of that also, so we would say wt is equals to g of node dash I of 1, and this is what nodes neighbor value. Okay, like this is the cost to visit that one. Now if the cost to reach this node, if the cost to reach this node, okay, added to the distance of the node, okay, added to the distance of the node, if it is less than the distance of the rest. Okay, like earlier kitni bhi distance ho, if suppose we are able to improve, if we are able to improve or if we are able to relax, if we are able to relax, first we would update it. Okay, first we would update it. So distance of rest is equals to this value. Okay, first we would update it. Okay, updation is done. Now we would insert that to the priority queue, push. So that would be nothing but this of res with the value of res. Now as I told, after popping out, okay, after popping out, we need to multiply the value with -1. Okay, and before inserting, you need to multiply the value with -1. Okay, so this value, okay, this value would be -1 into this. Okay, so this one would be -1 multiplied by -1 multiplied by this. Okay, I should be clear till this point. Next, what we need to do is we need to return the value of this. Okay, fair enough. Just quickly give me a 1 in the chat. If you are clear with this, then we would go ahead and we would try. So this is what? So relax. Okay, and these two paths are what? If relax is possible. This is this. Okay. This is minimum weight. Okay, minimum weight node. Okay, and this distance is already saved. Okay, quickly give me a 1 in the chat. Quickly give me a passage ट्रेन पे देखे ट्रम्प स्टेट हुआ दिमाग ड्राई रन करो यार नहीं समझता ओके फेयर इनफ ड्राई रन कर देते हैं let's take a screenshot of this and we would be able to do the dry run कर देते हैं भाई dry run okay let's take this example only okay so let's suppose as of now the value of int max is equals to 20 as said okay so initially the value of 0 1 and 2 everyone has 20 value everyone is initialized with 20 okay then I say here source is equals to 0 source is equals to 0 okay then we go to the distance of source and we assign it with 0 so we go to distance of source we assign it to 0 then we insert that in the priority queue okay we insert that in a priority queue let us draw a priority queue okay we would insert the priority queue so we would say that the cost is 0 okay and the node is also 0 so this side we are storing the cost this side is cost and this side is node okay then while the priority queue is not empty first we would take out the node so what is the node that is taken out 0 0 is taken out so node in the node thing 0 is stored at this point then we would remove from the priority queue so remove from the priority queue so temp node is equals to 0 now we would visit the neighbors of 0 okay so neighbors of 0 how we are visiting nodes neighbor is equals to 1 okay that is what this value is 0 so this weight is this one value so this weight is equals to 1 this rest is equals to 1 so if this weight that is 1 plus distance of node is 0 distance of 0 is equals to 0 distance of 0 is equals to 0 if 1 plus 0 is less than distance of rest what's what 1 so rest of 1 distance of 1 is equals to 20 if 1 is less than 20 then we need to update it so we would update it because 1 is less than 20 if we are able to first we would update it after updating we would push it to the priority queue with the negative multiplied by the distance So what is 1? 1 multiplied with distance is -1, and the node is what? The node is 1. Okay, this is the very first iteration. Okay, now this priority queue is still not empty, so this would go move forward. So what is the first line of code? Int max. Like this is initializing a vector of size v with every value as int max. Okay, int max is the largest possible integer value. Okay, int value. Again, this is the very first thing, that is node. So node is now what? 1. Node is now 1. Then we are popping it. So we would pop it. Okay. Then we are going to the neighbors of 1 and we are trying to visit it. Okay. So neighbors of 1. So res is equal to first. Okay. First it is 1. Okay. First it is 1. Okay. So sorry. This is 1. So neighbors of 1 is equals to 2. This is 2. Okay. Then WT. Okay. 2's value is equals to what is stored? 2's value is equals to 3, where t is equals to 3. So 2 plus 3 is less than whatever is stored, 20. So we are able to update it. So we would say that this value is 5. So 5 comma 2. So this is how we would keep going until the value is done. This is why making the cost -1 here. We are multiplying it with -1 to convert the max heap to min heap. By default, the code of this is max heap C++STL. That is why we are multiplying it with -1. So that is why it is written before pushing -1, after popping -1. Okay. So hope I'm clear with this. If you are not clear with this, send me a quick 0, and after this, we would leave. So today Dijkstra was explained from top to bottom. Okay. So quickly give me a 1 in the chat if this is clear. Okay. So, okay, I would just quickly submit this also. Okay, what is this giving us? Does not have a class type. Okay, we need to remember some. Okay, it's just that I need to remove some of this. Okay, I would just remove this code. Quickly give me. So, Mukshat, can you quickly tell me at what point you're not able to understand? Quickly tell me, Mukshat. So, I'm just removing all of the comments and all. Okay, that was written till this point, and I think I need to make here an AC. Okay. Yes, I have removed all the comments as well as I have added it. So now let us quickly submit this and see. Mhm. Yes, this is done. Okay, so now this is the very concise code of this. Please take a screenshot if you want. Okay, so then it multiply -1 with negative, then it becomes positive now. Yes, if it is becoming positive, then negative value would come to the top because of the elements in the max heap. So just do this on a pen and paper, how this is even working for negative elements. Okay, like whatever I claim is that the elements, be it either positive or negative, we don't really care. Whatever be the elements, what is iterating through in the for loop. Okay, what I is iterating through in the for loop. I is iterating the neighbors of that node which is there in present at the priority queue. It is just moving towards the other nodes of that one. Okay, so I see no more doubts coming in. So I would still wait for the next 30 seconds and then I would be turning off the session. Mhm. Okay. Any more? So let me see if I missed any doubts that was there in the very first time. Okay, I don't see any doubts, okay, at this point of time. So if you were here till this point of the solution, okay, or this point of the stream, consider liking the video and commenting on the video. Thanks a lot, others. So consider liking the video and commenting on the video so that this reach of this video could be increased. That is it for today. Thank you and have a nice day. Time complexity and space complexity. Okay. I missed it. I missed it. Okay. Thanks a lot, Stark. Okay. So time complexity. Okay. No. What is the color? Yes, this color is fine. Okay. So see, here we are just declaring the array and all. So this is constant. This is constant. Okay. Here we are pushing it. So this is what? This is just simply login. Okay. This is simply login. At the next point of time, we are accessing the top element. So this is again log n. This is again login. So if you observe that each node, and this is again less than, so again we are pushing it inside the priority queue. So to understand this, you need to understand that each node, okay, each node is given. So yes, so if you observe this, that in the worst scenario, for a particular node, it can edit all the other nodes. For the other particular node, it can edit all the other nodes. So the worst time complexity would be the number of nodes square and the auxiliary space in the same way. If it is editing all the other nodes, then we need to keep all the other nodes. That is why the expected space complexity remains the same. It is same as expected space and time complexity. This question is implementing the Dijkstra algorithm, so it is quite easy to understand. Okay, so that is it for today. Thank you and have a nice day. Good night, everyone. What does it mean? Line number 18. Line number 18. What does it mean? This is simply accessing the top element. Like this is simply taking out minimum element from priority queue. This is simply accessing of minimum element in the priority queue. V means vertices. V means the number of nodes. Okay. So what does it mean? This means this minimum element from the priority queue. Am I clear? Z's code. Can you quickly confirm? Line number 18 means that it is accessing the minimum element. Vertices or nodes. Okay. So do I receive any doubts quickly? I would wait for the next 30 seconds because I'm receiving doubts. I'm saying goodbye and again waiting. Okay. So I don't want any doubts to be left. Okay. So quickly tell me, quickly give me, uh, I would wait for the next 30 seconds. Okay. So if you have doubts, I'm just opening the code also. If you have some doubts, quickly ask it. Nice session. Thanks a lot, Z's code. If you liked it, consider leaving a like on this. Mhm. Nice water. Mark my attendance. Thank you so much. Not for this shirt, but marking your attendance. Okay. Okay, so there might have been instances in this live stream that I have said something wrong or I made a mistake unknowingly. So please understand that at the other end, a human is there. Okay, and I too make mistakes like you. So please consider those things. Thank you, everyone.